Okay, for this problem, we suppose that x is a gamma random variable with the expected value of x is 3/2 and the variance of x is 3/4. Find the probability that x is between 1 and 3. So ordinarily, when you have a gamma random variable, the values of r and lambda are given. This time, we have to figure out what r and lambda are. So we recall that if x is gamma with parameters r and lambda, then the expected value of x is equal to r over lambda, and the variance of x is equal to r over lambda squared. So I've got a system of two equations and two unknowns. R over lambda is equal to 3/2, and also r over lambda squared is equal to 3/4. So just using the bottom equation, this means that r is equal to 3/2 lambda, multiplying by lambda. Now I'll take this and plug in, so these two equations become 3/2 lambda divided by lambda squared is equal to 3/4. And so what do we get? So if I bring lambda squared over lambda on this side, that's lambda. Then if I multiply by 4/3, I get that lambda is equal to 2. And then if lambda is equal to 2, then clearly r is equal to 3. Okay, so there's the r and the lambda for my distribution. Okay, now I need to find a probability. Well, the density function is 1 over gamma of r times e to the minus lambda times x times lambda to the r times x to the r minus 1. That's the density function for the gamma distribution. So in my case, that's going to be gamma of 3 times e to the minus, okay, lambda is 2, so minus 2x times 2 to the third times x to the 3 minus 1, so x squared. Now 1 over gamma of 3. Gamma of an integer is 1 over that n minus 1 factorial. So that's one of my rules, that if I have an integer, that gamma of n is equal to n minus 1 factorial. So 1 over gamma of 3 is 1 over 2 factorial times 8 times x squared e to the minus 2x. So I end up with 4x squared e to the minus 2x as my PDF as long as x is greater than or equal to 0. That's the PDF. Now the question at hand asks for the probability that x is between 1 and 3. So there'll be integral from 1 to 3 of the PDF, 4x squared e to the minus 2x dx. Okay, and there's no simple way to do this. I just simply have to do the integration by parts, and I have to do it twice in order for it to come out. So this is integral from 1 to 3 of 2x squared times 2e to the minus 2x dx. Now the thing in the parentheses is the derivative of minus e to the minus 2x. And so applying the integration by parts, we get negative 2x squared e to the minus 2x evaluated from 3 to 1. Minus a minus becomes plus. Integral from 1 to 3 of 4x e to the minus 2x dx. Okay, we do integration by parts again. Okay, now this first part I'm going to evaluate at the end, so I'm just going to leave that carrying along for the ride. This part becomes integral from 1 to 3 of 2x times 2e to the minus 2x dx. And then applying integration by parts again, this part here is the derivative of e to the minus 2x as before. Then applying integration by parts, we get minus and minus becomes plus. Integral from 1 to 3 of the derivative of 2x is 2 e to the minus 2x dx. Then I integrate this. I get minus 2x squared e to the minus 2x. I've got minus 2x e to the minus 2x. And then on this last bit, I have minus e to the minus 2x. And all this gets evaluated from 3 to 1. And one way to check my work is to take the derivative of this and make sure that I actually get 4x squared e to the minus 2x when I plug in. All right, so plugging in, when x is equal to 3, we get negative 18 e to the minus 6. Then I get minus 6 e to the minus 6. On this part, I get minus e to the minus 6. Plugging in 1, I get negative 2 e to the minus 2, minus 2 e to the minus 2, minus e to the minus 2. And so putting this all together, I get 5 times e to the minus 2 minus 25 e to the minus 6. And so whatever that number turns out to be, that's the probability that x is between 1 and 3.